Hello. I tried flashing the ESCs for my quadcopter recently, and I'd heard that you could do it using just an Arduino, so I wanted to give that a try. It's probably not the easiest way to do it. Involves a little bit more hassle than some other methods that you can use. But as another YouTuber once said, I love hassle. So here we are. This is not something I'm going to be doing frequently, I think. So as much as to show you how to do it, it's also to show future me how to do it, because I'll probably forget sometime down the line. Hello, future Chris. Did you forget how to do it? Yes. Never mind. Anyway, so what you need to do this is an Arduino, of course, and because we're going to be plugging things in with some breadboard leads, the easiest Arduino to use is obviously an Uno, because it has the pin headers there to plug things in. So you need the Arduino and some, I think you need 6 breadboard connectors, and I'm going to use one of these, and this is probably the easiest way to get this done, and unfortunately it's not that cheap. I found this on Hobby King. This is one of these things here, ATmega socket firmware flashing tool, and it's about $20. You could probably find it on eBay or something as well, I guess, but this is where I got mine. And although it is a little bit expensive, I decided to get this because I'll be potentially using it a lot in the future. And it can also do flashing of any other kind of Arduinos that use this TQFP style chip. So for this video I'm going to be using this Pro Mini instead of the actual ESCs on my quadcopter, just so that I don't screw anything up. But like I say, yeah, any Arduino that has that style chip on it there, you can use with this tool to flash it. Also, I have here a couple of LEDs and a couple of resistors on a piece of breadboard there. This is optional, you don't need this, but it's quite handy to have some feedback, and so I'll show what this does if you do use it. And I just have a battery here to show, or just to power up this Arduino. So at the moment we can see it does nothing at all. So the program I've loaded on here is just an empty setup function and an empty loop function, doesn't do anything whatsoever. But we're going to upload a different program on there and make the LED blink. So yeah, like I say, if you're actually doing this with the ESCs for your quadcopter or your car or whatever, maybe quadcopter I guess, you'll find if you cut away the heat shrink, you'll find a very similar kind of chip in there, and this is most likely an ATmega 8. If we can get this to focus here, we should be able to read it. So it'll be something like that, and you can see in the top left of this chip there's a very faint circle which signifies the pin 1 corner, I think, of this chip. And I noticed on some of the other chips in the other ESCs that I have here, you can barely see that circle, if at all. Like some of the other ones, it's just almost invisible. But generally that circle will be at the top left if you're looking at the text the right way up, as we are here, like that. So if you have the text right way up, it should be in the top left. Probably a better way to show you what the circle should look like is to look at this one, where it's a lot clearer. Oh, come on. Alright, so you can see that circle clear as day there. So I think maybe the chips in the ESCs that we just looked at are kind of cheap fake copies or something. But anyway, that circle there, we're going to use this tool to press down onto that chip, and that circle should match up with the red dot mark on this corner of the programming tool. Okay, well, you can see there's a red dot there. Now this red dot looks to me like it could be rubbed off quite easily, but if you ever find that it does get rubbed off, you can look at the pins on the bottom here, and you can see that on the right hand side there, that corner has 3 very tightly spaced together. And that corner will be the opposite to where the red dot is, if you ever need to remark that dot yourself, just in case it gets rubbed off. So anyway, that's just the, well, it's actually 6 pins there, yeah. So to connect this all up, we need to have a look at actually, just before we connect it up, let's look at what we're going to be uploading onto the ESCs. So I'll switch over to my Arduino IDE, and you will of course need this IDE installed if you're going to be doing any of this stuff. And if I compile the Blink program, I'm not installing it on anything, I'm just compiling it, we can see the last line, second to last line of the output here. It should be doing something like AVR object copy, and then the final part of that line we can see is going into a .hex file. So that's the compiled output of this Blink program, and we can see there that it is at this location on my computer. So this should look exactly the same on Mac and probably a little bit different on Windows. I'm using Linux here, so that's why I say it should be almost the same on Mac. So what I've done to show as a demonstration is I've taken the standard Blink program as I just compiled here, and I've called that Blink Slow, and then I did this and I compiled again and took the output hex file from that version and I called that Blink Fast, and I just brought those over into this temporary folder here. So those are the two outputs from those two files, and these are the programs that I'm going to upload in this demonstration. Now obviously this is not a ESC controller program, it's just the Blink program, so you wouldn't be doing this to upload onto your ESCs. What you will be doing is finding a hex file that's precompiled, is probably the easiest way to do it, and there's a few places you can get those. In my case, I found it on, where are we? Actually, this thread here is the reason that I decided to do this flashing of these ESCs in the first place. But I found it I wanted to make absolutely sure that I was using the correct Simon K firmware on the ESCs that I was using. So I downloaded it from the link in this thread here. So you can download this and unzip that file, and you'll see a bunch of .hex files in there. So of course you can get these from many other places. I don't really have any good tips for where to find them, except for I did notice that if you're interested in using the BL Heli software on your Atmel chips, because the BL Heli is supported on Atmel now, you can just do BL Heli source, and there's actually a link there. It takes you straight to the Atmel subfolder, and then in here you'll see hex files. So there's just a bunch of precompiled stuff in there. And there's probably a similar repository for Simon K as well, I would imagine, but I haven't really looked for it. Now, I should also mention at this point, it's very, very important to get the right one for your ESC, because you could run the risk of ruining it completely. Fortunately, the BL Heli project has very, very good documentation, and particularly this file here. I looked at this earlier to check that my ESCs were going to work, and this has photos showing all of the supported ESCs and lets you know which version of the firmware to use for them. The ones that I used it with happened to be this one, the very first one, so I was quite pleased to see that I didn't have to search through this file too much. But anyway, this tells you that this ESC uses that version of the firmware, so that would be in these hex files folders. You can find whichever hex file you need there. So that's what I've done. For the real case, when I flashed this onto the actual ESC, I used files like that instead of Blink. So just for this demo, I'm going to use these blink.hexes. Anyway, okay, so getting back to the connections, we can see on here we have this kind of a pin header sort of a thing on here, and one side of it has a plastic tab here, and that plastic tab, if I hold this on the left, we can see that it's matching up with this diagram. So that's like that. And we need to make those 6 connections there between this and the Arduino. And actually, just before we do that, sorry, I'm getting a little bit out of order. Let's upload the sketch onto this Arduino that we need to make this function as a programmer. So if I go back into my Arduino IDE, I already have it open here, but you can find the sketch in the examples, and it should be near the top here. It's called Arduino ISP. So if you just open that sketch, you'll see this here. And there's some instructions here that we should pay attention to. So what we just saw in the connections for the programming tool, these are the pins that we need to connect those to on the Arduino. In my case it's an Uno, so it'll be 10, 11, 12 and 13. It'll be different for the Mega. And then there's also what I mentioned before. I have a couple of LEDs that we can use to get some visual feedback about what's going on. So we can put an LED with the resistor in series on pins 9, 8 and 7 if we want to get some information. So I'll just upload this to my Arduino Uno and see what that does. Okay, so now this Arduino will function as a programmer. And I'll just hook up my LEDs here so we can see what happens at this point. So that goes to ground, and I'm going to hook up 9 is going to be the red LED on here, that's the heartbeat one, and I'm also going to use 7 for the programming feedback, so this will flash a little bit when we're actually doing some programming. So now you can see the red LED is pulsing with a sort of a heartbeat display. And if I reset the Arduino now, this other LED is pink, so that's a little bit hard to see maybe, but if I hold it like that, so you can see that flash just a little bit when we reset. So that's the feedback LEDs. Now I'll just connect up the other connections here, and then we can get on with the rest of it. Where are we? This one. Okay, let me just do that. Okay, there we go. So all of those connections are kind of crammed into the same place. It gets a bit crowded there. But if you have different connectors that have this kind of a where are we? If you have connectors with this type of connection, you can actually find all of those SPI pins on this header here as well, which might be a little bit more convenient to use. Anyway, so now we should have the ground and VCC and all those pins coming out onto here as well. So just to check that you have at least got the ground and the VCC correct, line up the circle on the corner there and the dot there, and you have to keep this straight. But if I place this down here and I get it correct, the position is right, we should see that at least we've got power coming up on the Pro Mini there, like this. So all it's doing is providing power at the moment. So to get those hex files that we had uploaded on there, where are we? Okay, so to get these files uploaded on there, let's take a look at how the Arduino IDE does this first. Alright, I'll just upload the blank sketch onto my Arduino Uno again, just for fun. So let me upload this. Now if I scroll back up here a bit and look at the command that it executed right at the top. Let's look right at the top. Okay. Okay, so there's the command that we saw that created the hex file, and then after that we have this other one that does avr-dude blah blah blah, and then it uses that hex file to upload to the, in this case, the Arduino Uno. But there's a few other options here that we see, and we're going to have to change some of these to get this to upload as a programmer instead of taking the upload into the Uno itself. So the first one here we can see is hyphen lowercase p, and if I just open my command line here and look at the man page for this avr-dude program, we can look at what each of these command options mean. So the hyphen P is the part number, so we can see there's some examples here. This is the type of microcontroller that is going to be the destination of the hex file, the program. So in this case I uploaded this to an ATmega328P, and that was my Arduino Uno. Now we're going to have to change that, but for now I'll just look at the other ones. Hyphen C Arduino, that is here. So this is the type of programmer, and we're going to have to change this as well. And then we have hyphen uppercase P, which is the device, or on Windows it'll be the COM port that you are going to output this through, and then hyphen B is the baud rate. That should be pretty clear. The rest of the options we don't have to change except for the last one, which is the actual hex file that we're going to use, because I want to use mine that I have in this folder here. So that's how the Arduino IDE invokes this avr-dude command. So we're going to do something like that, except using these hex files. Now I have a little file here, which is my cheat sheet, and this is what most of the puzzle was, to be honest, to figure out how to what the right parameters were for this. So in the case where I uploaded this to the actual ESC rather than the Pro Mini, this is the command that I used. Of course I changed hex file.hex to the actual this correct type of hex that I was using for the ESC that I had. So the hyphen P, in that case rather, I had to change this to M8, and that is the ATmega 8 chip that we saw just a moment ago that I actually have in the ESC. So that's hyphen P M8 will be the right one for this type of chip. For this demo though, I'm using a Pro Mini which has a 328P chip, which is the same as what we have on the Uno, so I don't actually have to change that. Where did that go? The port I don't have to change. The baud rate, I'm going to change that to 19,200 because, as I noticed in the Arduino ISP sketch, in the setup function here, it's using baud rate 19,200 there. And the other very important thing we need to change is the programmer type. And instead of using Arduino, I'm using this STK500V1. And this one seems to make the... I'm not sure exactly how this works, but I found that I had to use this one to let the Arduino Uno function as a programmer instead of trying to accept this hex file into itself. So anyway, let me just copy this into my command line. And I have in this folder here those hex files. So if I copy that into my command line, and instead of using the ATmega 8, we use the same one that the Arduino IDE was using to talk to the Uno, because that's for the ATmega328P. So I'm just going to put that in there. ACM0 is fine, and we need to change the hex file to one of my hex files, which in this case I'll start with blink slow. Now that should be all I need to do, if I've got everything right. I hope I have. Now, if I hold this in the right place, and just keep your eye on the LEDs there, we should see some action from these. Oh, this is not going to work. Hold on a second. At the moment, the Arduino Uno still has the blink sketch on it, see? Just about made a mistake there. Let's upload the Arduino ISP one again. Okay. So now we can check that we have the heartbeat again. Now when you place this tool down onto the chip that you're flashing, just double check that that heartbeat is still going, because I've noticed sometimes that the heartbeat can stop. Maybe it's because I touched something a little bit funny over here, but if the heartbeat stops, the flashing is not going to work. You can, I think, if you just press reset on the Uno, you can get the heartbeat back if it stops. Anyway, so I'm just going to run this AVRDude command here and we'll see what happens. Oh, that's not right. Okay, problem. Not really sure what the issue there is. Let me have a look. Might just try that again. Sometimes this connection when you're touching here can be a little bit crooked or something. No, same problem. Damn it. Okay, forget about that. Let me just check my connections and I'll... Okay, I figured out what the problem is. It's probably the most stupid mistake you could make. Notice how I said there's a bump on the side here that should be matched up. I got that backwards, so all of my all of my connections that I plugged in here have been reversed. So anyway, that's a demonstration of what results you'll get if you get all those backwards. I'm surprised actually that the ground and the VCC still work. So I guess maybe they're yeah, that is strange, isn't it? Because ground would be on there and VCC would be on there. Huh. Anyway, let me rearrange these correctly and I'll see if we can get it working properly. Alright, let's give this a try now that I've got the pins around the right way, hopefully. I was quite surprised that the LED came on the Pro Mini there. I guess, no, don't know what's going on there. Alright, let's see if we can get this seated on here properly. No, oh god. Now I've got this backwards. Alright. Okay, and you can see I've tested already because the slow blink program is already on here. But anyway, let's try see what happens. So you can see the pink LED was flashing a bit there while it was uploading, and now if I power this from the battery, we can see that the slow blink program is on there. So that was successfully loaded, and let's just try loading the fast blink program on there just to double check. So that'll be like this. Hopefully get it right again. So I think what's happening here is I just don't have it held correctly. And I've also noticed that once again the heartbeat has stopped on the LED that's attached to the Uno, so I don't really know why that heartbeat keeps getting lost. But there it is back again. Nope. Maybe I'm just holding this wrong when that happens. It is a little bit finicky to get right. That feels good. Let's try that. Oh, heartbeat is gone again. Man, this is... I don't know why the heartbeat goes away. It's really annoying. Alright. Let's try that. There we go. So as you can see, it's not without its hassles. But once you have it set up and ready to run, you can do all of your ESCs all in a row like that. So there we go, now it's running the fast flashing hex program. So the idea is you do that once you get this system all set up. You just do that for all your ESCs and put the correct firmware on them that you want. I think what I might do with this actually is convert this messy system here to use a nano, and I'll just package it all up maybe so that it's heat shrinked and it'll just be a nano stuck on the top here, and you can just plug a USB in from the computer and flash things like that. Will be much more convenient than this setup with all the breadboard wires. Anyway, future Chris is going to do that, aren't you, future Chris? So anyway, I hope there was at least something useful to learn from this video. It didn't quite go as smoothly as I'd hoped, but then again, it's the kind of thing that doesn't tend to go smoothly every time anyway. Anyway, thanks for watching.